Hi, thanks for joining me today. I've got an infinite sum I want to evaluate. It's the sum of 7n plus 32 times 3 to the n divided by n times n plus 2 times 4 to the n. If you want to have a go at evaluating this sum, pause the video now and give it a go for yourself, but I'm going to dive right in. So what we're going to first do is consider this 7n plus 32 over n and n plus 2. And what we're going to do is split this into partial fractions. So this is going to be the same as a over n plus b over n plus 2. Now I could do this using the cover-up method, but I think I'm just going to do the kind of standard way. So I'm going to cross multiply here and essentially clear both denominators here. So multiply both sides by n plus 2, and I get this here. So 7n plus 32 is the same as a times n plus 2 plus bn. Now I can just choose different values for n. So if I choose n is 0, on the left side I get 32, and on the right side I have 2a, and so that means that a is 16. And if I now choose n is minus 2, on the left hand side I have minus 14 plus 32, which is minus 14 plus 32 is 18, equals, and on the right hand side I've just got minus 2b, and so that just means that b is minus 9. Cool, so now we can say that this sum here is simply the same as the sum from n is 1 to infinity of a is 16, so 16 over n, minus 9 over n plus 2 times 3 to the n over 4 to the n. Okie dokie. So if I split this up, this is a sum from n is at least 1 of 16 over n times 3 to the n over 4 to the n minus the sum from n is at least 1 of 9 over n plus 2 times 3 to the n over 4 to the n, like so. Okay, cool. What we're going to do is tweak this right sum a little bit. So we're going to keep this one the same, so 16 over n times 3 to the n over 4 to the n. And this one here, what we're going to do is multiply the 3 here by 9. So that's going to add 2 to the power. So we're going to get 3 to the n plus 2. And now this 4 to the n, I want to make that 4 to the n plus 2. So I'm multiplying the denominator by 16. So therefore I've also got to multiply the numerator by 16 as well. So I get 16 over n plus 2 here. And now the great thing about this is these two things look awfully similar. In fact, they are essentially the same thing. What I'm going to do is what we call an index shift on this second sum. So the first guy stays the same, so it's the sum from n is 1 of 16 over n times 3 to the n over 4 to the n. And this second sum here is going to be the sum from n is at least 3 of 16 over n times 3 to the n over 4 to the n. So all I've really done there is I've changed these n's, or I've essentially subtracted 2 from the n values here and added 2 to the n values here. And if that doesn't convince you, maybe just plug in n is 1 here. If you plug in n is 1, you get 16 over 3 times 3 to the 3 over 4 to the 3. So that's just this sum here with n is 3 in. And now the great thing is most of these terms cancel out. We're starting from 1 here, so we have an extra 2 terms here, but apart from that, everything else cancels out. So we're just left with 16 over 1 times 3 to the 1 over 4 to the 1, plus 16 over 2 times 3 to the 2 over 4 to the 2. Now we just got to evaluate this. So this first term, 16 over 4 is 4 times 3, that's 12. And then here the 16 and the 16 cancel out, so I've got 9 over 2 here. I'll just write that as 4.5. And so this is just 16.5 altogether. And that would be the value of this sum. A nice little solution here, and I guess the numbers have been chosen in quite particularly to get this nice result of the difference of two squares. A nice little trick. I hope you have enjoyed this video. Please do give it a like if you have, and subscribe if you haven't already. Thanks for watching. I'll catch you in the next one. Have a great day.